This is going to be lesson 8 in our solving equations unit. It will be on special solutions. The homework will be pages 16 and 17, and there will be a unit test Friday, May 12th. So I have a couple warm-up problems if you want to pause this video and try them. It's just solving for the variable on both sides. So starting with my first one, I have 2x minus 5 equals 10 plus x. I'm going to move my variables to one side. So I'm going to subtract x from both sides, so this cancels out. And I will have 2x minus x, which is x minus 5 equals 10. I'm going to add 5 to both sides, and I'll get x equals 15 for my first one. Then look at the one down here. I have negative 4g minus 8 equals negative 9g plus 12. Again, I want to move my variables to one side. So I'm going to add 4g to both sides. This is going to cancel this out, so I'm left with negative 8 equals negative 9g plus 4g is negative 5g plus 12. I can subtract 12 from both sides now, so that will cancel out. I have negative 8 minus 12, which gives me negative 20 equals negative 5g. And to get g by itself, I can divide by negative 5, and I will get 4 equals g for my next one. Now, jump back up to this one. I have 3f minus 7 equals 5f plus 3. I can subtract 3f from both sides. So I have negative 7 equals 5 minus 3f gives me 2f plus 3. I can subtract 3 on both sides. This negative 7 minus 3 will give me negative 10 equals 2f. I can divide by 2 on both sides, and I will get f equals negative 5. Now, for my last one, I have 2z plus 6 equals 36 minus 3z. I'm going to add my 3z to both sides. So that cancels out on this side. So I have 2z plus 3z, which gives me 5z plus 6 equals 36. I'm going to subtract 6 from both sides. So I have 5z on this side. And then 36 minus 6 is 30. I'm going to divide by 5. And I will have z equals 6. All right, so moving on to our lesson. So if we open up to page 17 in our notes, it says special solutions at the top. I actually want to skip over this little chart first and look at the 3 examples below it. They're going to have variables on both sides. So I want you to take a chance right now and pause the video and solve each of these 3 equations. Now, looking at equation number 1, I have 3x plus 4 equals 5x minus 10. I want to solve for x. So I'm going to put a line down the middle, and I want to move my variables to one side. I'm going to subtract 3x from both sides. So this will cancel out. So I'll have 4 equals 5x minus 3x gives me 2x minus 10. Then I can add 10 to both sides. 4 plus 10 will give me 14 equals, this cancels out, 2x. I can divide by 2, and I will get 7 equals x. Now example 2. I have 9m minus 4 equals negative 3m plus 5 plus 12m. So first, I actually want to combine my like terms on this side. So I'm just going to rewrite. I'm going to erase this a little bit. 9m minus 4 equals. So I said I want to combine my like terms. I have negative 3m plus 12m. So that's going to give me 9m plus 5. I want to get my variables to one side. So I'm going to subtract 9m from both sides. But they both cancel out, and they leave me with negative 4 equals 5. And we all know that does not make sense. That does not work out. Moving on to example 3. I have 10x plus 12 equals 2 times the quantity 5x plus 6. So solving this, on this side I'll have 10x plus 12, but we have to distribute on this side. So 2 distributed in, so 2 times 5x gives me 10x, and 2 times 6 gives me 12x. And if we just notice right there, they're the same on both sides. Because if I was to subtract my 10x to get my variable on one side, I'd still get 12 equals 12. So the same thing on both sides. Now, looking at each one of these examples, I want you to notice something. Because we're talking about special solutions, don't all of these solutions, the ending factor, look different? If we look at this first one, we got x equals 7. We got one solution. When we look at this, we got negative 4 equals 5, which doesn't work. So there's no solution. There's no true m to make this equation work. And then over here, we got something special where both sides were the same. They were equal to each other. That's what we call something, we call that an identity, where we would have infinite solutions for x. So, looking back up at our chart, special solutions. When we're solving our equations, we're always going to have one solution, no solution, or infinite amount of solutions, or what we call an identity. So, in your chart, we're going to fill that in. Under one solution, we're going to say, when solved, we get one value which makes the equation true. So, for example, below, our first example, we got x equals 7. That is a one solution equation. So looking at our no solution, when solved, we get a value that makes the equation not true. So again, looking at our second example below, we got negative 4 equals 5. That is, they're not equal to each other. That doesn't work out. So in that example, there is no possible solution. There's nothing to make the equation true. So for our last one then, our infinite solutions or identity. When solved, both sides of the equation are identical or the same. So we have infinitely many values that would make the equation true. So, in that last example below, we got 10x plus 12 equals 10x plus 12. Or when we tried to solve and take away the variables on both sides, we just got 12 equals 12. So both of our sides were identical. They were the same. So that means we could plug anything in for x, and we could get infinitely many solutions. So, down here, I want you to then just write below our answers that this is one solution, no solution, and infinitely many. Alright, so on the next page in our notes, all of these examples have variables on both sides. So I want you to solve, and then I want you to write whether it's a one solution, no solution, or infinitely many solutions. So starting with our first one, we see we have to distribute first on this side. So I have 2 times quantity x minus 5. So I'll have 2x minus 10 plus 3x plus 4 equals, on this side I have 8x plus 9 minus 3. At this step, we can see we need to combine our like terms. We need to simplify this. So on this side, I have 2x and 3x. I also have a negative 10 and a 4. So on this side, my 2x plus 3x gives me 5x, and my negative 10 plus 4 gives me a negative 6. On this side, I have a 9 and I have a negative 3. So I have 8x, negative 9, or 9 minus 3 will give me positive 6. And now I can just solve. I want to move my variable to one side. So I'm going to subtract 5x from both sides. So this cancels out and leaves me with negative 6 equals 8 minus 5 will give me 3x plus 6. And I'm going to subtract 6 from both sides. So on this side, negative 6 minus 6 gives me negative 12 equals 3x. Divide by 3, and I will get negative 4 equals x. I came to one solution. I got one answer. So this is going to be a one solution equation. Looking at my next example, I want to distribute to start off with. I have 6 times the quantity x minus 3 plus 10 equals 2 times the quantity 3x minus 4. So on my first side, I'm going to do 6 times x, which gives me 6x, and 6 times negative 3, which gives me negative 18, plus 10 equals my other side, or I'm going to distribute 2 to my 3x, which gives me 6x, and then 2 times my negative 4, which gives me negative 8. I'm going to draw my line, and I'm going to solve. So first I notice I can combine these. I have 6x, and negative 18 plus 10 gives me negative 8. And we can notice that they're the same on both sides. So I can just stop right there. And this one's going to have infinitely many solutions. Now, we look at example 3. I have 8 times the quantity 4 minus 2x equals 4 times the quantity 3 minus 5x plus 4x. I want to distribute first on both of my sides. I have 8 times 4, which gives me 32. Then I have 8 times negative 2x, which gives me negative 16x, equals, on the other side, I have 4 times 3, which gives me 12, and 4 times negative 5x, which gives me negative 20x, plus 4x. I can draw my line and start solving. I see on this side that I can combine like terms. So I'm just going to rewrite 32 minus 16x on this side equals 12x. So I have negative 20x plus 4x. That will give me negative 16x. I want to move my variable to one side. So I'm going to add 16x to both sides. And I see that I'm left with 32 equals 12, which we know is not true. So this is going to be no solution.